Greetings. Just a quick run through of taking this data for the projectile lab and doing the calculations and then plotting the scatter plot. So if you recall, this is the data we collected, and by the way, this is for both classes this year, all of third period, all of first period. Of course, first period has the morning announcements, which are legendarily long, so you didn't get as much data. That's okay. I'm going to do it for all the data combined. You should at least do it for your class. If you want to do it for all the data combined, that's fine as well. So the other term that we're plotting, h is on the y-axis. On the x-axis is not actually this value for x. It's actually going to be 4.9 times x squared. So this is just a descriptor of that. This is what that represents, 4.9 times x squared. Here's how we're going to do that. In this cell, we're going to hit equals, and we're going to type 4.9, and the little asterisk, the multiply thingy, and this, click on this cell. Do not type in 3.103. You don't need to do that. That's why we use spreadsheets. Otherwise, we just use a calculator. You click on that cell, boom, it'll put that cell's value right there, and we're going to square it, which is the caret, the second shift 6, and 2. We're squaring, and we hit enter. And there it is. And what we'll do now, so we don't have to type all that much, because typing is so difficult. Like there were 12-year-olds that, like, back at the turn of the century, would like leave and go work in a factory for like 15 hours a day, and we can't type too many things. But anyway, I digress. I just click and drag it down, highlight that entire thing, and I hit hold down Control and hit D for down. See, that's the direction we're going. Boom. We don't need all these decimal places, so I'm going to go here and let's see. We want to reduce the number of decimal places to like 3, I guess. That'll make sense based on significant. I'll go one more. Go down. There we go. So now we are going to plot this column right here is going to be our x value, and our y is going to be the h's that we see here. So I'm going to do this. I'm going to copy this h column. I guess I could move it too, but in this case I'll just copy it. So I'm going to go Control Copy. I'm going to paste it right here to the right. And the reason I paste it to the right is the computer is going to assume the first column, the one on the left, is my quote x, and the next column is my quote y when it goes to make the scatter plot. Okay, so I highlight both rows. Now it depends. I don't know. Sometimes it's better to highlight the heading as well and do all that. Sometimes it's just good to do the data. I can never remember which one's better. Let's try it with the headings and see what happens. So do that. And I'm trying to remember here on this one, I've got to go over to Insert Chart. Click on that. I'll wait. It says something about using. Oh, look at that. It uses something like that. Yeah, okay. We'll call it. Why not? It works. We got our data range already selected. Somebody took an outlier here. Look at this. That's what we call an outlier. We're going to deal with that in a second. It is already selected actually on mine as a scatter chart, but of course you could scroll through and find the scatter chart if it's not already. And then I think customize axes and titles. No, that's not it. It's here. Oh, series, I think. It's got to be here somewhere. We're going to find it. Don't worry. We're going to find it. Legend. It's here somewhere. There's a way to do the best fit line. I'm still looking. Trendline. I missed it the first time. There it is. So let's go back. Where is that? It's under series. So you go to series, click Trendline. There it is. Linear. That's fine with us in this case. All right. And we'll show the r squared. Now, here is the r squared. Where's my actual trend line? We'll go Label, Use Equation. Now, we have a bit of a problem with our r squared value. It has a bad r squared value. You know why? Because this data. And we're going to get to the bottom of this. This little point up here, that's an outlier. That is a nasty, ugly piece of data. We need to find it and fix it or get rid of it. That is either a typo by me or somebody in one of the classes took some crappy data. Let's find out if it's third or first, shall we? So I'm going to hover over it. Oh, a second ago it was just going, no, there it is. Let's see. Height is 8.843. That doesn't seem realistic, does it? No. So I think maybe the culprit here is me with a typo. I think I can see where it is. Let me see if I can move this stupid chart out of the way. Now let me move it. Yes, thank you very much. There it is. You see it? All right. So I'm assuming that's 0.843. Bam. All right. We're not doing too bad. I still have some data here that I'm a little bit suspect of, to be honest with you. In this case, I'm thinking it is, quote, bad data. 0.84, another one of those 0.843s. Trying to find these data points and see if it will let me get rid of them. Let's see. 33.38, so that would be, there it is. I saw it. 33.38. There it is. So something's up with this one. And this makes sense to me because if one of them went, if at that height it went 1.9 one time and almost a whole meter farther the next, that's like the definition of bad data. So, let's see what happens when we just delete those 2 points and see if that actually gets rid of that point. I think it does. Oh, look, our R value got better. Let's investigate this one, shall we? 1.365. 1.365. And 56.4. This one. Once again, here we have 1.365 going 2.4, and then all of a sudden it's going, now maybe I mistyped this. Maybe instead of a 3, it should be a 2. We'll go with that. Let's try it. Notice, if I change that, if I have to go, it will, as soon as I hit enter, it recalculates everything. See, so that's one of the reasons we do it the way we do it. Now let's go after this one. Height was 2.05 and 67 was the number, so let's find 2.05, 67. Alright, I'm going to get rid of this one completely. I'm not sure. It just doesn't seem to fit with the others. So let's do that. Alright, look at that. Now we're up to 0.959. So we now have what I would consider a decent line, and we can take the slope from it. Now the slope, if you'll notice, is right here next to the x. It's the 0.0368. That is our slope. That, my friends, is going to be equal to 1 over the original velocity squared, if you look at your notes in the lab packet there. And so we're going to solve that for the original velocity and have that ready to go for the next class. Here endeth the lesson.